So a vibration has a unique path lifting if and only if every fiber has no non-constant paths or no non-trivial paths. So this result we have seen, right? Now, following things are direct consequence of the things that we have already seen. So we have theorem. The composite of vibrations with unique path lifting, unique with unique path lifting is a vibration again with unique path lifting property. So this proof is straightforward. You just use definition, and so this you can try this exercise. And then we have another result, which also is straightforward. The product of vibrations with a unique path lifting is a vibration with a unique path lifting. This also is straightforward. So next we have following lemma. Let P from E to B be a vibration if A is any path component of E, then PA is a path component of B, and if we restrict P over A, then it is a vibration from A to PA. Vibration. So we will see proof of it. since P is continuous, uh, and A is path connected, so every path component is actually a maximal path connected subset of E. Right? Every path component of E is a maximal path connected subset of E. So since P is continuous and A is path connected, PA is a path connected subset of this is a path connected subset of P. Okay. Now we want to prove that basically PA is a maximal path connected subset of B, and hence PA will be a component of B. So we want to prove that PA is a maximal path connected subset of B. If omega is a path in B that begins or that starts, so that is omega 0 belongs to B, right? So in a path in B such that omega 0 belongs to PE. It starts from PA, right? And where it ends, we don't, we are not specifying. It may end outside PA, it may end inside PA, whatever it is. Then there is a lifting, right? There is a, then there is a lifting omega tilde of omega that so because P is a vibration, so we have already seen that given any path, right? Given any path omega in B, there is a lift, right? There is a lift of it in E, right? So let omega tilde be a lift of omega that begins in E. So such thing exists, right? Because already we have discussed this, that if P from E to B is a vibration, right? And omega is a path in B, right? And if mm, this if your y naught is a point in P inverse omega 0, you can say, then there is a lift. Then there is a lift of omega tilde, right? Such that, of course, omega tilde P is omega, means omega tilde is a lift, and omega tilde starts from y naught, right? So we have this. So this omega P inverse omega 0 will be contained in A. Sorry. So P inverse omega 0 will intersect A. So we can choose a point which is in A and also in P inverse omega 0. So we have this. That begins.
तेल मसला आएर चाहिँ हैन 11 जना जामको तर्स लु अब लाग्यो त्यस्तो भयो मलाई दियो
Yeah. So now since A is path connected, that path component, so omega tilde will be completely is a path component. Omega tilde completely lies in A. Hence, omega equal to P compose omega tilde completely lies in P, right? With this, PA is maximal path connected subset of B. Hence, PA is a maximal path connected subset of B. Hence, PA is a path component of B. Hence, PA is a path component of B. Now, we want to prove that P restricted over A is a vibration from A to PA. Let F from Y cross I to PA and F prime from Y to A be maps such that uh, f y comma 0 equal to uh, p composed f prime y for every y belonging to capital Y, and this, yeah, so this much. Now since P is a fibration, of course this map I can consider this this is a subset of your B, and this is a subset of E. Since P is a fibration, so basically this is a map from, you can consider this as a map from here to B, and this one map from here to E. Since P is a fibration, there exists a map f prime from y cross I to E such that P f prime equal to f and f prime y comma 0 equal to f prime y for all y belonging to capital Y. Now our objective is to show actually that its image of this f prime is actually contained in this A. So that is what our objective. So for any y belonging to Y, this f prime maps y cross I, right? Because y cross I is what? Because I is path connected, so y cross I, this is homeomorphic to I. So this is path connected. So capital F prime is continuous, so it should map this path connected set into a path connected set. So this map this uh, maps this into a path connected set, right? Now so because this uh, now F prime I is path connected uh, and contains it contains f prime y comma 0, right? Which is what this is, this, right? But f prime y, you just see f prime is a map from y to a, so this is completely contained in e, right? Thus f prime y cross I is uh, uh, path connected, path connected, connected, and f prime y cross I intersection A is not equal to empty. Just see, this is, this belongs to this, and this belongs to this also. So this basically I can write like this. Belong to this. So because A is a hence uh, f prime y cross I is completely contained in E. Okay, because A is a component, path component, and uh, uh, any path connected set either does not intersect A or it is completely contained in E. Only two possibilities are there. So f prime, this intersects A, hence it has to be contained completely in E, right? So because y is arbitrary, right? So f prime y cross I is completely contained in E, right? So this completes the proof. Therefore, uh, f prime from y cross I to A is a lifting of f from y cross I to uh, PA such that such that this f prime y comma 0 equal to y. So this completes the proof. Next, we'll discuss another result. So theorem, let P from E to B be a map if E is locally path connected, then P is a vibration if and only if and only if each for each uh, path component A of E PA is a path component of B and P restricted over A from A to PE is a vibration. So if E is locally path connected, then these two things are P is a vibration and this property. This is they are equivalent, right? So one side already we have proved in the lemma. Uh, if P is a vibration, then uh, for then uh, for then from previous lemma for each path component A, PA is a path component of B and P reciprocal over A from A to PA is a vibration. We'll discuss converse. Conversely, let suppose that for each path component A of E, PA is a path component of B and a vibration. Now, we want to prove that P is a vibration. Okay, so let F prime from Y to E and F from Y cross I to B be maps such that uh, F prime Y equal to P compose 0 for every Y belong capital Y. Now let AJ be the so these are all the path components. all path components of E. Then, so we have already seen that means this. So if a space is locally path connected, then of course it is going to be locally connected, and hence this all the this no. So from here itself we can conclude that all the path components are actually open. So this you can see. Uh, so let Aj be the all path components. Then so of course path components will be disjoint, and uh, then they will be open also. This is uh, uh, disjoint open subset of E such that E, J, E, J. Right? They cover, right, this E. Let Vj equal to F prime inverse Aj. So because F prime is continuous and each these Aj's are open, so these Vj's are open, and because these Aj's they are disjoint, so these Vj's they will be disjoint. Clearly, this Vj, this is a disjoint open cover of, this is a disjoint open cover of Y. Right? Hence, to construct uh, to construct a map F prime from Y cross I to E such that E compose F prime equal to F and F prime Y comma 0 equal to F prime Y. It is enough, right? It is enough to construct maps Fj prime from Bj cross I to E for all j such that E compose j equal to F restricted over Bj cross I, and fj prime y comma 0 equal to f prime y. Because what you have is actually uh, so if you have disjoint any suppose this is E sorry so if we have this is y cross I, so this you are if you are able to break it into disjoint open sets, right? Then defining some map over this, it is enough to define over these disjoint open sets and then combine all of them because there are no intersections between these open sets, so there will not be any problem, right? So only thing is that if you write y class I as union of open sets, uh, and if they intersect, then means when you define maps on different open sets, then they should agree when their domains intersect. But here their domains will not intersect. So we just arbitrarily define maps from here to here, 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 and then you will have a map for y cross I. So since f applied over y cross I, so you choose, let us choose for any y belonging to Vj, f applied over y cross I, because f is continuous, y cross I is path connected, so f y cross I is going to be path connected. So it is going to be contained. So since this is contained in a path component of B. Why? Because this is path connected, so it is going to be completely contained in a single path component uh, of B, and this f y comma 0 equal to P compose f prime y. This is uh, contained in where? This is contained in your PAJ, right? Because you just see that this y is in Vj, it means f prime y belongs to Aj, because Vj or f prime inverse Aj. Okay, but then when you apply P f prime y, this belongs to P of Vj, and P of Aj is a path component, and since Paj is a path, uh, thus Paj is a path component of B, such that uh, uh, this Paj intersection, this f of y cross I is non-empty, right? Hence, uh, f of y cross I is completely contained in P of Aj, that is P F of Vj cross I is containing P of Aj. This is true for all J. Now, since P restricted over A from A J, P restricted over Aj from Aj to Paj is a vibration and uh, this F prime Y P compose, sorry, and this capital F Y comma 0 equal to P composed F prime Y. This is basically P restricted over Aj, right? For every Y belonging to Bj, right? Uh, uh, there exists maps Fj prime from Vj cross I to Aj such that P composed Fj prime equal to F restricted over Vj cross I and Fj prime Y comma 0 equal to F prime Y for every Y belonging to J for all J, right? Uh, Hence, this is what that was which was required for getting lift, right? IF prime. So this completes the proof. This completes the proof.